Hi, everyone. We're just going to give the audience maybe 60, 90 seconds and we'll get cracking. Thank you so much for joining us, for those who have already. Good folks, we're about to hit 70, and so we have. So on that note, let's get started. Welcome, everybody, to Sylvera's Accelerating Project Registration and Issuance webinar, broadcasting from London in Canada. It's us from Sylvera, and not to be strangers, quick round of introductions. Myself, Gav, I'm VP Product here at Sylvera, and I lead our geospatial intelligence business from product perspective. Together with Ellen and Rex, who are joining me today, we're going to be leading this. Ellen, off to you.
Hi, yeah, I'm Ellen. I'm a technical climate consultant here at Sylvera. So my role is essentially to act as the technical voice in many of our commercial conversations, including our discussion around geospatial support. Rex?
Yeah, I'm Rex Devereaux. I'm a geospatial data scientist. I work on our data products, and I also live in the trenches with all things methodologies.
Lovely. Let's jump into what today is all about. So we're going to start slightly bigger picture. Where is the market at? Where is it going? What's driving it? What challenges come with that from project developer, investor, and other perspectives? And then what the session is really about is sharing very tangible hands-on insights. How should you be developing your projects to make sure you get to the outcomes you're after, be it registration, issuance, as quickly and robustly as you can? What are the pitfalls to avoid? What lessons have we learned by supporting the carbon ecosystem in the space ourselves? So hopefully you could take away some practical insights from this session. There's also a give at the end. We're going to get to it. All organizations participating are eligible for a free VM47 eligibility screening or applicability screening. You can call it either. We'll share the details towards the end of how you can access those. We're probably going to present for about 40, 45 minutes. Then we're going to jump into Q&A. Thank you, everyone who has submitted questions already. We've gone through them, clustered them together. Ellen is going to be emceeing the Q&A session. If you have questions throughout, put them in. We'll try getting to them in the end, or if they're highly synergistic with what we're presenting, we're going to weave them in. But without further ado, let's get cracking. So first and foremost, why are we here? Why are we having this discussion now? It's mid of 2026. It's a nice time to look back and see what the market is doing. And we were talking about market in this context. We're interested in the forward market, so the market for offtakes. What we've seen, having collated hundreds of offtake agreements, 2025 blew all the previous years out of the water, north of $12 billion worth of offtakes announced. We just split them here, ARR, non-ARR. The non-ARR part primarily is durable CDR, so engineered removals. And what's also interesting is the price point, for various reasons, significantly higher in the offtakes market as opposed to where it's at in the spot market. Spot market is hovering in single digits. Forwards market is hovering north of $100. If you cut this picture by volume, then it really starts telling you why should we be talking about ARR and why that's an interesting time to be talking about it, or NBS more broadly. Just the first half of 2026 alone, we've seen offtakes for more than 12 million tons worth of ARR credits. And just to put that in perspective, that is more than all ARR retirements in 2024 and 2025 combined in half a year. So we're running at 4x the clip rate. And while 2025 was an extraordinary year, let's see where 2026 lands. Definitely there's a year-on-year trend, which is pointing in the direction of market growth here. Now, this is all fine and dandy. Why is it happening? What is the sort of the qualitative evidence behind it? Let us share a few insights with you on that. So first of all, when we talk about these offtakes, ARR, and other nature-based solutions, they are pretty much exclusively coming from what we would call DMRV-enabled methodologies. Your VM47s, your equitable Earth methodologies, your isometric methodologies, VM48, and so on. It's no longer a hypothetical, so Q2 saw the first issuance of VM47 credits. They are available on the spot market, those that haven't been secured already through offtakes. So it's not sort of pie in the sky is going to happen years down the line. It is happening in the market, including in the spot market. Another tailwind is DMRV methodologies universally over-index on CCP eligibility. We see a lot of buyers still caring about CCP. There are SBTI announcements. Whenever you have this third-party credentialization of what someone is doing in the space, that's a massive tailwind in the project sales. And this is very much true of DMRV methodologies and projects following them. The last one I would describe as a double whammy. So it's the challenge and the opportunity. So the market is changing in terms of what projects you can develop in terms of the role that DMRV is imposing on it. And I would actually say that's increasing the complexity and the challenge for project developers and others in the space. But what we've seen is buyers, off-takers, investors are actually setting their expectations even higher where the new DMRV methodology bar is in terms of the sort of data they want, the robustness they expect, the monitoring capabilities they ask of investors, and how they think technology should be empowering that throughout the project lifecycle. So we're going to cover all of these. I'm going to hand over to Ellen, but long story short is we're in a market that's showing very positive signs of growth, and there are a number of trends that are, hopefully make sure that these are sustained and continued. Ellen, let's go to the challenging part.
Yeah, thanks, Gav. And obviously, there's a lot of opportunity in the DMRV and ARR market. We've talked, obviously, Gav just mentioned about the offtake volume and the commitment for forward offtake agreements, but that doesn't mean it's easy to execute on. And from speaking to a lot of different developers out there, we kind of hear of like 4 key challenges that a lot of developers are facing when they're engaging with these methodologies and trying to implement them in practice. 2 of those sit in the actual methodology itself. So many of the methodologies, such as VM47, which is obviously what we're focusing a lot on today, requires performance benchmarks and dynamic baselines to be developed and implemented as part of the methodology. This is a new requirement for in carbon markets. A lot of the legacy CDM or older methodologies don't ask for this type of analysis. So even for long-standing developers, this might be something they've never done before. So this might be a new step in the process, which always just takes a bit longer and is generally just always challenging to figure out something new. The second thing around the methodology is that the early inputs, so the early decisions made in the project design, determine the downstream results in many of these projects. So things like what stocking index to use, or the control plot radius, or the forecasting method being applied can have significant impacts, both positive and negative, on the project's ability to issue credits in the future. In the data and verification side of things, generally what we see is good data is scarce and it's often expensive. So kind of a double whammy. So even a project that uses like a 100-kilometer donor zone radius can be using up to 3 million hectares of data. So to get that from a private or public source like Sentinel Earth, you may be able to use these free sources, but it might not give you the granularity, the data quality, or the historic coverage that you need for your project. That volume, on the other side, sometimes working with a private or different data sources that you pay for is a large volume of data. We know that that can be an expensive undertaking for a lot of developers. Lastly, data quality and processing determines the VVV timelines. So projects entering first verification without traceable evidence can face like a multi-month VVB review cycle. So we know already that going through this process takes a long time. Vera processes can take up to 2 years, similar sometimes with other registries. And adding an extra hurdle of having good enough data for that process can make the timeline even longer and more challenging. Perfect, Gab. And then we jump to the next slide for me. And what we see is that for basically every project, they're all going through this same kind of core sequence of steps. So looking at the ex ante to ex post universe, and this is more of a grounding slide for us. I'm going to hand over to Rex in a minute, who's going to take us basically through every step in detail. But I wanted to kind of put it front of mind of how we think about it and how the market is considering these different steps. So in the ex ante world, there's 4 key steps. So thinking about applicability. So can you develop a project under this methodology? There's the development of the donor pool. So where will I source the counterfactual for my baseline and my donor pool? And then you have the actual development of the dynamic baseline. So what is the counterfactual, which then allows you to build the performance benchmark? And fundamentally, these are that's answering for what do you know about the project's ability to issue in a forecast? You then obviously repeat a similar process in the ex post world where you want to repeat the dynamic baseline and the performance benchmark once you actually have actual ground data. So that's our kind of frame of reference for this more technical conversation. And I'm just going to hand over to Rex to start talking you through those steps.
Next slide, please. Yeah. Steps and learnings we found associated with them. So first here, we have our applicability screening. Confirm that credits can actually be generated from some given area under a given methodology. So this is also a good opportunity to look at potential expansion areas and beyond the initial instance so that you can plan for the future. The main challenge here is assembling all the required data layers. However, we find there's a significant synergy between the data needed in doing applicability and the donor pool. So in this example here, we can see about 10% of this area is ineligible. But if you're interested in this in general, we have a detailed case study on our website. There's a link in here in the slides. Next slide, please. Next in the process, you have your donor pool creation and sourcing of control plots. So for VM47, BVBs generally look to see the full 100-kilometer buffer use beyond the project area. And as you can see on the right here in this chart, this results in millions of hectares of data, which if you're purchasing can get pretty pricey. So defining the donor zone before you even purchase data is quite helpful because then you're only paying for pixels that you actually need in the process. Another step you could implement once you've purchased the stocking index data or built it yourself is filtering for statistical similarity. This is something that's mandated by isometric. And what it does basically is you can speed up the matching process without sacrificing quality as you're simply removing all the poor matches up front as the stocking indexes are statistically insignificant. If you go to the next slide, please, Gab. Yeah, you can see this effect here. You might have to squint, but these areas in blue are those that are statistically similar using the stocking index of AGB. And you can see it's really only a small proportion of this entire 100-kilometer buffer. So you can cut out a lot of the data in the processing step here to speed things along. And now we can go to the next. So Ellen alluded to this earlier, but your choice of the stocking index itself, once you've created the donor pool, has a pretty big impact on everything downstream. We generally see 2 buckets of stocking indices. One measures physical characteristics like biomass or canopy height, and the other measures greenness or some kind of greenness index. These usually are like NDVI or EVI. So when we look at kind of the trade-offs between these, on the left, you can see a plot of AGB and EVI changing over time. Note that the AGB is generally near zero. This is an area of degraded land, but the EVI fluctuates annually, and the changes of the distribution of the values actually change within the area itself, which is somewhat erratic. You have greener parts moving around the area, which is not very yeah, it's rather counterintuitive. When you look on the right, when you aggregate this out to a mean, you can see the same effect. So you have EVI bouncing around year on year, whereas the AGB is just a steady growth. And so why this matters is because when you introduce noise early on, you're going to get noise downstream. Next, we can move on to forecasting. So if you're doing an ex-ante performance benchmark, everything's going to be determined by your project's forecasted growth, right? So there are a few options here. You have bottom-up modeling. So this requires suitable literature to exist for the species involved, but gives you more control over planning schedules, density, mortality, thinning, everything else to do with managed forests. There's also stand level approaches, which can capture species and site interactions that a tree by tree approach wouldn't capture well. And then there's also remote sensing methods. One we use is geared towards natural regeneration. So what you do here is you use peer groups of growth stage forests and mature forests to inform a growth curve, like a Chapman-Richards function. But generally, the thing to keep in mind is there's no single correct way to create a forecasted curve. It all depends on the project context and data availability, but whatever you choose is going to impact your results in the end. So putting all these kind of ideas together, we could see an example here of an ex post performance benchmark penalty for a project using different stocking indices. So in dark green is AGB, it's above ground biomass, and in yellow is EBI, a greenness index. So a few things jump out looking at this chart. Using AGB, you see the penalty is higher at the beginning of the project, but notably this would be applied to a very small amount of removals, given there's an S-curve of ARR issuance. The value continues to decline over the next 2 years as biomass accumulates and ends up near zero, resulting in a steady near zero performance penalty. So this is pretty ideal for project financing and to have stable issuance. You know what your performance penalty is going to be in each year beyond the first few. On the other hand, when you look at EVI, we can see the penalties are lower in the beginning of the project, but counterintuitively rise over time. You also see more year-on-year changes in either direction. This is similar to the example that was shown earlier, remembering that noise as inputs is going to result in noise as outputs. So in this case, both of these are technically valid results. They pass the statistical significance test, but one results in significantly less credits and results in potential headaches for this project. And finally, a few scattered observations about doing this process. When you're doing this, you need to think about how many years of data you need. We've seen people start creating, a stocking index using 10-meter Sentinel-2 data, only to find out that they can't meet the 10-year requirement under Vera. So as the data only goes back to 2017, and then you're starting from scratch again. You also need to consider image quality in the data you get. So you need to think about clouds and seasonality. Obviously, clouds are going to result in big data gaps, which need to be addressed by some sort of gap filling method. And depending where you are, seasonality can also play a significant role. So to kind of illustrate these 2 points, this is an example over West Virginia. On the left here, you have an image from July with the leaves on, which is green, but there's a lot of clouds. And then there's an image from December with the leaves off, which is clear. Images are usually clear in the winter. And then finally, there's a composite here. This isn't just a combination of these two images, it's the whole stack throughout the year. But basically what's happening here is we're using a greenest pixel algorithm. So you don't just take a simple average of all available images, but you blend the scenes when the leaves are on so you can actually capture realistic biomass conditions. Uh, Finally, you can run into headaches with mixed activity types. Say you're doing part of the project is natural regeneration and part of it is a more traditional plantation. The matches and the rate of change in controls and project pixels are going to be completely different. So we generally advise stratifying the performance benchmarks in this case. Otherwise, the result you can get poor matches because it's just a large distribution of possible outcomes.
Cool. Thanks. Thanks, Rex. And obviously, today is very much focused around the practitioner point of view and the more technical observation. But we also thought it'd be useful to bring some of our more big picture market observations to the call.
But sorry to interrupt, Ellen. I just
Yes.
wonder before we jump into those, there were a couple of good
Yeah.
questions that came. Speaking, I think, to the points that Rex has covered in. Oh, we're not at Christmas in July just yet. My word. Okay. Maybe let's just quickly weave in a couple
Go
of
for it.
questions that Leonardo and Alice have provided in the Q&A session here. I think one, probably Rex most suited, you're most suited. Let me generalize it a bit. My question would be, how about soil organic carbon? Like what role does it play? Rex, maybe you can speak to like what do we see in terms of like the carbon pools involved in these projects that we typically look into.
When it comes to the dynamic baseline itself, soil carbon isn't considered because you're just using a stocking index. It doesn't need to capture all of the different carbon pools. That those different pools come in when you're calculating the actual removals associated with a performance benchmark penalty. So at this stage, soil carbon isn't a consideration. No.
Okay. And then there was a question from Leonardo, which I'm happy to take, which had to do with what we talked about forecasting, which obviously is required for an ex ante performance benchmark. Now, the approach that we take truly depends on the project's characteristics. So if we're looking at natural regeneration, we will prefer to use remote sensing based approach. If developers have field measurements, we can locally calibrate our data products just to make sure they are as tight as possible. Now, if it's a case of, say, a monoculture plantation of non-native species, remote sensing and inferring based on the surrounding vegetation is not going to yield accurate results. Then it might be a literature-based review and a bottom-up model based on planting regime, cohorts, S-curves, etc. So it is context dependent. And then how different are the forecasting methodologies for agroforestry? Maybe it's a good one to weave in at this point as well. The question is, like, can you see below the canopy? Because there are different types of agroforestry, and we will typically just run sensitivity analysis. If there's an early planting cohort, can we actually pick it up in remote sensing data? If you have sub-canopy and neither optical nor radar nor other signals can penetrate through the canopy, then that's not an appropriate method to use for forecasting. We need to appreciate, by the way, that this is all ex-ante performance benchmark. We talk about these as DRMRV-enabled methodologies. The actual issuance is still underpinned by field measurements, even in VN47. There's one way. There are multiple ways of deriving the forecast, but in terms of the actual issuance, it's all driven by field measurements, which you can then sort of extrapolate over the project area using remote sensing data. Ellen, I think it's a good time to jump to your parts.
Yep.
We have a couple of raised hands. Maybe we open the floor a bit after you're done with this page. Sounds good?
Yeah, sounds good. Yeah, let's do it.
Lovely.
And I know we also have a few questions people submitted in advance as well, so we can also talk through them, which would be great. But yeah, as a reminder, we also here at Sylvera, we talk to a lot of buyers and investors. So um, often the requirements for developers reflect very positively on when you're entering into these discussions with buyers and investors. So we kind of just wanted to lay out some of these, I guess, like tips and tricks we've seen and what works well. Um, and they're very similar, both on the left and the right, but I'll talk through both. So for developers, um, what we see works really well is starting, obviously some of these are really obvious, but starting your data and documentation strategy early in the process. So making sure that you are detailing and documenting the decisions you're making as you go through and the parameter choices you're making. So things like, why did you choose a 60-kilometer donor zone radius versus a 80 or 100-kilometer donor zone? And being able to justify and evidence why you made that decision and why essentially that is a better choice than choosing something else. We also see, and when we work with developers, we do this as part of the process, but we often share multiple stocking indexes. So Rex has talked to the difference between NDVI and AGB. So they can yield very different results that can also lead to very different outputs in terms of issuance ability. So we suggest that developers look at least both of them, and you can consider others as well in the decision-making process. So you're choosing the right one for your project and your project context. And then lastly, what we have seen work really well, and the same with going through the VBE process, is having both a full technical process document that lays out these decisions and the steps you've taken, but also providing a plain language summary. So thinking about how would a non-technical audience be able to interpret and understand the results that are in front of them? I'm not a geospatial expert. I would say that for someone like me, being able to read a plain language summary is a really important part of having a project documentation so that others can use and engage and interpret the results. In a similar vein, for buyers and investors, a lot of these are basically coming off the back of this best practice I've just mentioned. But things like suggesting for buyers and investors to choose projects with conservative defensible parameter choices, which links to having sensitivity tables and laying out your decision-making process. Prioritize best-in-class traceable data sourcing, not just the cheapest available. And ensure evidence claims aren't being gamed. So making sure your stocking index choice is justified against the alternatives. So as I said, looking at multiple stocking indexes and making the decision that fits and is right for your project is also going to look well and benefit you in these discussions with buyers and investors because they can see the alternatives. And then lastly, similar, maintaining a full paper trail. So both for developers, but also for buyers and investors, it's useful to track decision making. And if you do sort of screening or validation of projects before you decide to invest or make pre-purchase agreements, what are the steps you've taken to make sure that project is eligible for the methodology and is on track to be of high integrity and actually deliver on time? Some market observations. Gab, I'm not sure if we have any other questions or we want to open the floor to some hand raised, or what do you think would be most useful?
Maybe just one question that we had from. I'm hoping that I haven't. Oh, from Sebastian. Rex, maybe you're in best position to answer that. Sebastian's question was about using a global AGB product for stocking index, field plots, LiDAR, locally calibrated biomass model. And what role biomass atlas plays in this equation. Would you mind taking this? And then, I'm furiously replying to a couple other who have submitted theirs. Thanks for those.
Yeah, happy to do that. So I'll answer directly, but first to keep in mind for the stocking index itself, honestly, the absolute value, whether the biomass says it's 10 or 20, doesn't matter so much as having a reliable source of signal change over time. That's the same reason people are able to use, NDVI, which is a unitless number. So it's something to keep in mind. Obviously, that would be different if you're measuring actual removals, right? Then you would always want you would want something quite reliable in terms of the absolute value. But so in the case where a project has field plots, It's probably not extremely additive because there's issues with correlating field plots to remote sensing data due to there's a few sources there. You have geolocation, you just have timing in general. But if you had LiDAR in your question here, that's a much better data source to calibrate a global model with. So you can basically take the global outputs and then calibrate them with the LiDAR data and get a more accurate local representation. So that would probably yield better results in absolute terms. But again, it might not really change the rate of change in the signal itself because you're basically the signal is the same either way. It's the same like satellite composites going in. It's just what the absolute number is going out.
Thanks, Rex. I do feel that we have a couple of hands raised. Let me just quickly check them. Bear with me. I think Frieder and Leo had their hands for a while, so we're just going to limit to those two hands. But Frieder, if you're still on the line and have a question, feel free to come off mute and fire away. Interesting. We might be having technical issues. Frieder, feel free to put the question in the chat, and I think the other hand has gone down. So in that case, let us continue. And actually is yours truly, Christmas in July. So what is this all about? What we've done so far with you, we've told you about where the market's headed, what different steps are involved in getting to performance benchmark, let's say an ex-ante performance benchmark. The challenges involved, some practical tips and tricks of how to overcome them. Now, we're speaking to you because we have experience doing that, working together with product developers, with investors as well, using proprietary data, Biomass Atlas, which we offer as a standalone product as well. We've invested quite heavily in pre-wiring these analyses, so we think we can execute them quite rapidly around the world in different project contexts. And the other thing that we recommend everyone does, this is something that we've done, any sort of analytical work, have it well documented. So, if and when it's shared, you basically have a repository of answers that whoever is asking questions, BBBs, investors, off-takers, standards, you can avoid the back and forth, which we see typically taking up a lot of time for project developers. You can spell out different analytical steps that you've taken, which are obviously aligned with methodology. If you have those documented, that document typically answers the vast majority of questions. Just to put this in perspective, the full write-up of a performance benchmark calculation, our current living and breathing document that we share with every single performance benchmark we produce, is about 8 pages long. Like, that's the fidelity that eventually you need to get to. And doing this time and time again, we feel we have cost and speed advantage versus, say, someone for whom it's a once in a blue moon situation. Now, don't take our word for it that we do this and it's worth people's time looking into it. We have an offer. We have something that we're giving away for free for you to experience at least a sprinkle of it. So at the end of this call, when we're going to close the conversation, you're going to see a form, which if you fill it in, it will allow us to get in touch with you, ask for your project's boundary, and then set 20 minutes with you, having run a preliminary VM47 applicability screen for that boundary, showing you our findings, what we're seeing fundamentally what our data is showing. So if of interest to you, fill in that form at the end of this webinar. If for some reason something wouldn't work, drop us a note at contact+47screen@Sylvera.io. So that's the give. As I said, there's a form once we wrap the webinar, and we're making good time. We're at the 35-minute mark. So I'm going to hand over to Ellen. And Ellen, if you don't mind, please field probably over the next 10 minutes questions you sort of collated from the registration forms. And for everyone's visibility, we were focusing on things that came up time and time again. So, just to make sure that we answer questions which are as relevant to as many of you on the line.
Yep, perfect. Thanks, Gab. And we there is a couple other questions in the Q&A, and if you have any other questions, this is your time to put them in the box. So, Rex, I think this is a question for you that we've received throughout the webinar. But someone is asking, how does the performance benchmark account for areas with intermediate initial biomass? So things like forests that have been affected by fire, drought, edge effects, or selective logging.
Yeah, this is a good one. I mean, the performance benchmark process is honestly quite well geared to this, and it just comes down to matching. So you're going to have, say, you have a degraded area to start with in your project with intermediate initial biomass, then you're going to match on those same areas in the donor zone. So really nothing changes. It's that distribution of values the algorithm is looking for is going to change. And so naturally you kind of expect the performance benchmark penalty to be higher in these kind of projects because there is some initial biomass that's already growing. Whereas if you're doing a plantation and you're looking at near zero starting biomass, I mean, trees don't always just appear out of anywhere. So that's why you can plausibly have like a near zero performance benchmark throughout the project's life, where in this case you wouldn't. But the algorithm is the same. It's just the distribution of values changes.
Okay, nice. And then Gab, a question for you, and thinking again about this investor discussion angle and how essentially a lot of this work has to also run past investors or potential buyers. Um, which outputs of this process do you think are an investor should prioritize when they're assessing an early stage project?
So speaking from real experience in terms of actual pieces of work that investors have come and asked us to support them with, we find that interestingly, they are very, very focused on applicability screening just to make sure that projects are ticking off all the boxes. And as Rex mentioned earlier, there's a big synergy between executing applicability screens and donor pools. But oftentimes, what we'll see is investors being interested as much in the project area as they are in the adjacent area. So, what you'll typically find is there are some players in the space who are looking to deploy capital beyond what a project can absorb, just given the project's current area, say a couple thousand hectares. And they will typically ask us the question of, is the starting project area applicable? And then treat the donor pool not as a donor pool, but a future project expansion area. In which direction could this project be moving, literally, sort of spatially? Where could I be expanding this project in which particular direction? Those, I think, are the two questions that we get asked most frequently. And then the other one, which sits at the very other end for performance benchmark calculation, if this is step one, the very last step that you need on top of the baseline, is the forecast. So everyone is interested in, what is an independent perspective, not developers, not maybe the investors, but another point for triangulation, or maybe even multiple scenarios that we can create at Sylvera using different approaches. Because fundamentally, an investor thinks about two things. One is project integrity. What is the quality of this project? But the second one is delivery on time in full. How likely is the project to deliver? So, long story short, it's either the very first steps that investors want to achieve certainty and expansion opportunities, or the last step where they want additional forecast to get triangulation points.
Nice. And then one of the questions we saw quite a few basically asking us about was around our data set we have here at Sylvera. So how do we collect our data? How do we build our data sets that get used in performance benchmark? Do we use allometric equations, locally collected data? So I'm not sure, Gab, Rex, either of you want to talk a little bit more about our biomass data?
Rex, do you want to kick us off, and then I'll top it up if needed?
Yeah, sounds good. So we've been building a large data set of both ALS and TLS data around the world, which is applied to our global biomass models. We also supplement that with other ALS and TLS data sets we can source. But that's the main source we use for training data for our Biomass Atlas product. which has significant advantages over, Jedi labels or something like this, because we actually can capture volumetric um, stem densities of the trees themselves. So you get a much more precise view of the subcanopy volume of biomass compared to, just the alternative like allometric equations. We're using tape measures to fit some kind of simplistic model. So that's what we use for our biomass product itself. And then for forecasting, it really depends on what method we're using. Um, we might use Biomass Atlas if we're using natural regeneration, doing a remote sensing approach, or we might just go to literature if we're doing some sort of bottom-up modeling based on trees planted and their associated species. But when it comes to actually implementing these projects, like we are happy to work with clients and take their input and data as well when we're constructing forecasts, because ultimately it's not our project, it's our client's project, and we don't want to put them in a box.
Yeah, I think that's bang on. Little to add. Ellen, before you jump to other questions that come from what people pre-submitted going into the session, the couple just came in just now. One attendee asked about the tremendous amount of money that you need to put into the project. Like, what is the minimum project size at which it becomes feasible? It starts with your projection of your yield per hectare and expected price point, which is a function of project's quality. We all know the correlations between quality as proxied by ratings and price. So unfortunately, we can't give a richer answer than it depends. But one thought I want to leave you with is one thing that you have in your gift is thinking about your monitoring cadence or issuance cadence. And what we've seen people do is try to gauge whether they have a project that they will want to verify every single year, every 3 years, every 5 years. And even where methodologies require field measurements for the actual verification, for the actual issuance, we see people benefiting from remote sensing data to get a ballpark estimate of how much carbon they have sequestered, therefore what potential revenue pool they're looking at, and therefore what their expected costs are going to take out of that revenue pool. And you might have a back of the envelope heuristic where you do not want to run verification unless you can retain, I don't know, say 80% of your returns from the credits, having spent 20% on fixed costs like VDBs. So just a quick tip is you can use remote sensing data to time the cadence of your issuance. Now, again, how big a project needs to be upfront, this will depend on the yield per hectare, your expected price point, and how much, how capital intensive it's getting off the ground, which is going to be different around the world. And on the question about we're talking about ARR, how about IFM? Transparently, we see ARR as a project type to be, together with RED, slightly further ahead of IFM in terms of its embrace of remote sensing and DMRV more broadly. I mean, ACR is doing good work with 2.1, their methodology for US forests on non-federal land. We think that market is less mature. That's why we put more emphasis on ARR here in the session today, which we think is aligned with where the market is at today. Ellen, over back to you. I think let's do maybe 2 more questions from what got aggregated from the submissions, and then
Yeah, that sounds good. And I think actually we had another question that along the similar vein as the IFM one around mangroves. So can we approach mangroves in the same way as we do ARR, or does that have to be taken in a different way?
Here, let's switch roles. Like Rex, let me give a preliminary answer, and then you tell me if there's anything to add. Now, mangroves conceptually is no different than, obviously there's a question of, are we trying to forest mangroves? Are we trying to run a RED project of mangroves? Mangroves are notoriously different to your typical standing forest in terms of the below ground biomass that's accrued there. Very, very transparently, we think that remote sensing products available now on the market are not yet well calibrated for mangroves. That's why the next field campaign that we're planning to execute over the course of Q3, Q4 here at Sylvera is actually doing multi-scale LiDAR work on Indonesian mangroves to get the training data set that will allow us to have what we think are world-leading accuracy-wise estimates of mangrove carbon pools. So conceptually, it's no different. The question, what is the data quality that's already available in the market? We think it's not sufficient. We are trying to do something about it. And we're doing it the Sylvera way, which is putting on our wellies and going and doing LiDAR work on mangroves later this year. Rex, anything to add?
No, nothing to add.
Okay, perfect. And then I think the last question, unless we get any last minute ones coming in, was around how feasible is the implementation of the performance benchmark in a grouped project? So that is including a project with multiple areas, but also that covers different forest types, but also covers different planting dates and varying baseline conditions. So basically a project that's really dynamic and diverse.
Yeah, it's definitely possible. Generally, how I'd approach it is actually just creating different performance benchmarks based on either significantly different activity types or significantly different cohorts in terms of planting dates. So if you have, a traditional plantation, like a monocultural plantation, the rate of growth, the starting biomass, and therefore the matches and everything is going to be completely different than the example we mentioned earlier, where you say have some degraded forest due to logging or fire. Again, those matches and the rates of growth are going to be completely different. If you were to coalesce those all into one project, you might even just fail due to match quality because the distribution of values is all over the place. So you might not even be able to get off the ground. But then also you're going to have this mixing of performance benchmarks. If you're starting from a patch of dirt and planting trees, you'd actually expect performance benchmark to be around 0 in a few years, but that wouldn't be the case for natural regeneration. So it's basically about cutting up the project based on logical boundaries.
Nice, thanks. And I think that's most of the questions we were going to cover. Gab, I'll let you wrap it up.
Okay, so as mentioned previously, if you're interested to see, Sylvera in action when it comes to these DMRV-enabled methodologies and associated projects, we're more than happy to, start with a give, which is a free preliminary VM47 applicability screen. Fill in the form after the webinar wraps, or drop us a note at contact+47screen Sylvera.io. Otherwise, thank you so much for your time. And there were also, last closing thought, there were a couple of questions in the chat about, for people who want to learn more, how could they do so? So I invite everyone to visit sylvera.com. Under products, you're going to find both sections for Methodology Toolkit and Biomass Atlas. The latter includes a detailed technical report. And then you can also sign up for a free account of our platform. Go to the Geospatial Intelligence section and see a couple of interactive demos using our actual in-house data of how an applicability screen looks like, how a donor zone looks like, how Biomass Atlas can be used for project monitoring. And then hopefully, the market continues on the trajectory that it has picked up as of the last couple of years. And, if we of any help, you know where to find us. Thank you, everyone. Thanks, Rex. Thanks, Ellen. Thanks for all of those joining. Double thanks for those all submitting questions. Hope you have a great day.
Thanks, Gab. Thanks, everyone.
Thanks all.
Cheers.
Bye.